Just a quick video, folks. I'm going to show you how to build this FM transmitter. As you can see, it's got a microphone. It's not a type of transmitter you plug music into. There's plenty of them. I've got some of them on my channel. Come and have a look. This is a microphone, very sensitive microphone too. This will pick up a whisper from across the room. I'm going to show you how to build it. It's running off 4 AA batteries, because it's cleaner than using one of these. These are quite noisy outputs, and a lot of them won't work with these transmitters because of the low current draw. This is the module from AliExpress. So the price there, that's cheap. Frequency range 76 to 110 megahertz, which is great. So I can use this outside the FM band, for the radio band, sorry. So you won't disturb your neighbours or anything, or anyone else to pick it up. Look at the price of that. Great modules, very stable. This is a simple build, not many parts. This is great. This has got a few days run time, maybe 3 days run time before you recharge your batteries again. Should we build it, folks? Well, here we go, folks. It's arrived from AliExpress. It literally took about 6 days, so it definitely didn't come by boat. Well, it's come well protected, I'll try that. There we go. That's quite a small device, isn't it? Focus. It's smaller than I thought, but it looks well constructed. Looks well put together, doesn't it? Can't mind for the price, can we? Okay, folks, we'll have a quick look at this circuit. They've packed quite a lot in a small circuit board here, really. Microphone, you get 2 buttons. This one here, that's to change your frequency. Only goes up in frequency because this right button here, that changes the sensitivity of the microphone. So there's 6 levels there of the microphone sensitivity. 2 transistors here. This will be your audio amplifier circuit, all this bit. This chip here, it's 8-pin chip. That's the microcontroller. I think that's based on the 8051 microcontroller. That's a 4K flash memory, 128 bytes of SRAM, an on-chip EEPROM. I think it's programmable up to 35 megahertz, I believe. Probably a bit of an overkill really for this circuit. This small chip here is a 3.3 volt regulator with a 12 megahertz crystal here. This chip here, this is the main transmitter. It's a QN8027, fully featured, complete FM transmitter. Frequency range 76 megahertz all the way up to 110 megahertz. They ain't the best, but it does the job for this simple transmitter. Very stable. Obviously, frequency is rock solid. What we'll do, we'll have a look at the next one. This will be this output transistor. The RF signal coming out of, I think it's pin 5 on this transmitter IC. Goes to the RF output goes to the base of this transistor. It's an NPN transistor. It's an S9018. It's an RF transistor. Well, these come from China. I am going to try, maybe in a later video, different transistors here, so I can get a higher RF output. But these transistors, they're mainly going AM, FM amplifiers. It's only a low power, obviously. I think the RF output's about 15 milliwatts, so It'll get this to a few hundred metres anyway. Quite a neat little circuit really, isn't it? Okay, what am I going to power the circuit with? Ideally, it'd be one of these power banks. But there's two problems with these. One, they can be a bit noisy for transmitters. And secondly, most of these, I'll say 99% of these, I've got a minimum current output. So the transmitter having a very low current draw, I think it's about 30 milliamp. This is just going to turn itself off after a few seconds, so that's useless. What we will be using is this enclosure, 4 AA batteries with a on and off switch, so that's ideal, isn't it? And because we're using batteries, the sound's a lot clearer instead of using one of them. Okay folks, this is the parts we need for this quick transmitter build. Obviously a transmitter, bit of heat shrink to go over it just to protect the circuit, an antenna, bit of velcro, and obviously the battery enclosure or box. So it's not a lot, only a couple of parts. Should we connect this up and test it first? That's a good idea, isn't it? Before we test it, I'm just going to cut these power leads because they're a bit too long. So we'll want to cut them about here. Always use flux folks, it makes soldering a lot easier. Okay, let's get the power connected up and soldered in. I wouldn't normally solder like this folks, but I'm trying to film at the same time. Remember the flux, I think I put too much on, but alright. It's power. Before soldering the antenna, I'm going to test its RF output. I think the seller claimed 15 milliwatt output. It does sound a lot, but that'll get you, you know, a few hundred foot. We'll test it with this meter here. This goes up to 1/4 of a watt. So it's 10 milliwatt, 20, 30, 40, 50 milliwatt. So we'll put it on there. We'll solder the RF. We'll solder that into the RF output. And we'll see what we get. Okay, should we solder this in so we can test it? The ground. So our output. Okay folks, that's that in. That's ready to rig up to my little RF meter. I'll pop some batteries in. Make sure it's off. Yep. Let's connect the RF output to the meter. Okay, does it work folks? Hi, there we go. Let's turn it on, let's get it in one shot there, that's it. Oh, we've got about 9 milliwatt there. It's a bit less than I'm trying to claim. Obviously when you go up the frequency, it goes up and down in power. but that'll be about its max anyway. I know that from experience with these. But what we can do, you can mess about with this RF output stage, try different transistors. You can adjust the gain of the transistor. So we can definitely get more. I think you can mess about this RF output and get that up to about 50 milliwatts quite easily. But we know it works. Let's quickly check what frequency we're on. Obviously when I try this in the garden, I'm going to put it just below the radio band, so obviously I don't interfere with anyone's radio. It's on about 91 megahertz. Yeah. Because it's going into the dummy load, the signal's weak. Once I've got the antenna on it, we'll check the frequency then. But we know that's definitely working. That's say about 9 milliwatts. Not too bad. Okay, let's disconnect this now, it's no longer needed. We'll put the antenna in. Okay, antenna next. Whenever you use one of these wire antennas, just go online. Once you've got your frequency you know you can use, or the spare frequency, whatever like, just cut your antenna to size. So you'll get one of these online calculators and it'll tell you the length of the antenna. So make sure you do that. Let's get this soldered in. Lovely. That's the antenna in. What we'll do, we'll just clean up the flux. Looks a mess, doesn't it? That's better. What we need to do now is just put some heat shrink on, just to protect the circuit. I've ended up about there, so it just exposes the switches on the mic. What I want to do, I'll overlap just the back of these wires, so I can crimp that tight at the back, just to crimp these wires tight so that they don't get any fatigue and work loose. And I'm hoping this gets tight enough, because it's a bit big. Please be careful when you do this while working with an hot flame. So just be careful. Just take your time and don't burn your fingers, please. Okay, it looks something like that. It's probably a bit longer at the back than I would have wanted. I might just put some hot glue in the back there, just to stop the antenna moving about, well, the lot of them, so they don't work loose and pop out. Okay, let's get the Velcro on. That's it, just stick it to the bottom of the transmitter, like that. This battery case is not smooth, it's quite textured, so what I'll do, I'll just drop a bit of super glue on the bottom. That's it, a couple of drops of super glue. Ain't going nowhere then, is it? That's it. Get it in position. Right there, should we say. Just hold it down. Just going to shove some hot glue down the back, just so the wires don't work themselves loose. Like that. Lovely. That's quick and easy, isn't it? Now we can get to the buttons. Microphone's exposed. No, all complete. Don't look too bad, does it? Huh? If you put 2000 milliamp hour batteries in this, rechargeables, you could probably get 2 or 3 days continuous runtime. Shall we put it in the garden and see how sensitive the microphone is? They are great. They're better than you think. If you do build one of these, folks, please don't use it on a normal radio frequency. So obviously you disturb others, which is totally illegal. Use it on a radio similar to this. You can buy them cheap actually. You can buy a lot of radios that pick up low frequencies. Got a standard radio is 87.5 to 108 megahertz. Well, this, if I turn it on, as you'll see. Now look, that goes as low as 64 megahertz, which is great. It's ideal for these type of things. So you can use them outside the radio band like. So I do recommend you use it on the lower output, or the lower side of the frequency. What we'll do, we'll check it can broadcast on its claimed frequencies. Well, it's 76 megahertz to 110 megahertz. So what you see there is the local radio stations and national ones. I've got the antenna down so it doesn't pick up all the radio stations. It just makes it a bit clearer to understand. Now every click of this button is 0.5 megahertz, so it's quite an high resolution. So if this got a frequency output from 76 to 110, what will that give you? That'll give you 68 channels. So you've got plenty of channels to choose from. Shall we turn it on? Oh, there we go. Now it's not a very clean output. As you can see, the bottom of that bulges out slightly. So that's why you want to stay away from radio stations really. That bleed over slightly. It's only cheap Chinese transmitter, so frequency. The output is not going to be that clean. So we're on 76 megahertz, 77, 78, 82, 84. I'm in the middle of a forest here. There's no one near us, so I'm not going to interfere with anyone, and I'm not in the UK. There's 89 megahertz. Is that focusing? You can hear me clicking it. Actually, the output's got a bit cleaner. Oh, that's strange, isn't it? 96 megahertz, 97, 98, there's 100 megahertz, 101, 102, 103, 104 megahertz, 105, 106, 107, 108, 109, there's 110 megahertz, so it definitely does 110. Oh, you can see the frequency at 76 is not very clean, is it? It's back to 76, so yeah, it does its claimed frequency. That's good. You can see as you go further up the frequencies, the signal does clean up a bit. Cool. It does its claimed frequency. Okay, folks, does the audio work? Let's get my frequency counter on. That's on 86 megahertz. As you can see, 96. Oh yeah, we've got feedback. Yeah, that's definitely working. Let's take the transmitter outside now. We'll listen to the wildlife in the garden. Let's pick that up then.
I've just noticed all those, right?
Yeah, come with that. I'm just going to take this outside. Oh, you can hear the birds. In the middle of a forest. So we just place that there. Let's just pop upstairs. Back to the radio. Listen to that. You can hear everything. Oh, look at that. I can hear a dog barking. Oh, it picks everything up, doesn't it? Very sensitive. I've got it on the eye setting. Great that, isn't it? Build one yourself. Have fun. Great little transmitter. Very stable. Great for wildlife, security, anything really. I hope you enjoyed that video. And I'll see you all soon.